In this video, we'll discuss one application of derivatives in the field of physics. We try to use calculus to analyze the movement of a particle or object moving in a straight line, right? So let's see that you have a straight line. You can label the 0, 1 in that straight line. You can get a position function, right, of the particle, right? S equal to f of t, right? This is the position function of a particle moving in a straight line, right? Left and right. And because velocity is just the rate of change of position, right? So the instantaneous rate of change gave you the velocity, right? In another word, velocity is basically equal to ds over dt, right? So this is the velocity function. If you want to differentiate more, the rate of change, the velocity, is called the acceleration, right? So the acceleration a of t equal to dv over dt, also the square of s over dt square. Second derivative of the position function you get is the acceleration function. So let's use this connection between position, velocity, and acceleration to analyze a movement, right? Let's say example. Example here. We have a particle moving in a straight line. Follow this position function as equal to t cube as of t, right? Minus 6t squared plus 9t. And s is measured in meters, and t here is measured in seconds. Right? I try to answer a few questions, right? Natural questions. And the first one here is, after you are given the position function, can we find the velocity, right? Find the velocity at t. By our discussion, we know v of t equal to ds over dt. That's an easy function to differentiate. You get 3t squared minus 12t plus 9, right? So that's basically what we have. And because later we want to decide when the function is moving in the positive direction, when the function is moving into the negative direction, when the particle is moving in the positive direction, when the particle is moving into the negative direction, which means velocity to be positive or negative or at rest equal to 0. Let's try to factor this function before to prepare that calculation. I factor this function, you get 3, you get t squared minus 4t plus 3, so you get 3 times t minus 1, t minus 3, right? So B here is when the particle is at rest. At rest means velocity is 0, right? We know that velocity equal to 0 when t equal to 1 or t equal to 3, right? When t equal to 1 or t equal to 3, the velocity is 0, so that's when the particle is at rest, right? Let's go to C here. When the particle is moving forward. Forward means v here, positive, right? Velocity is positive, that's moving forward, or backward, and the v here is less than 0, right? How do we do that? We can analyze this equation here, right? We know time has to be greater or equal to 0. So if you have time is less than 1, both terms are negative. So yeah, it's 2 negative give you a positive, right? So you can try to draw a diagram, right? This is from 0 to infinity. You have 2 0 points for the velocity, right, which is 1 and 3, right? This is our time. From 0 to 1, both terms are negative, so velocity is positive, right? From 1 to 3, one term is negative, one term positive, so this is negative and positive. If you have t greater than 3, both terms are positive, right? And so this is what's going on here, right? So we can get that v of t is positive when t here is greater than 0, less than 1, and t here is greater than 3. V of t is less than 0 when t here is between 1 and 3. When t equal to 1 and 3 or 3, and then this particle here is what? Is rest, right? Velocity is 0. Now let's see D here. D here is draw a diagram. Draw a diagram. We try to understand how does the particle move, right? Represent the motion of the particle, right? So, okay, let's try to draw this straight line. The particle is moving on, right? We want to sketch our motion, right? If you plug in t equal to 0, for sure the motion is 0, right? And the particle for sure from time equal to 0 to 1, the particle is moving forward. So starting from 0, moving forward, right? When t equal to 1, the particle stops. So this is t equal to 1. T equal to 1, but the position may not be at 1, right? T equal to 1 as a 1, if you plug in as a 1, you get equal to 4, right? Then after that, the particle moving backwards, right? Because when t equal to when t equal to okay, when t equal to when t is between 1 and 3, the particle is moving backwards, right? and backward until t equals 0 and t equal to 3. Until t equal to 3, the particle stop again. And after that, if you can calculate S of 3, S of 3 is also 0. So the particle stops at 0 again, then change direction to positive direction going forward. After that, always going forward. So this is a diagram representing the motion of the particle moving positive direction, then go backward, then go forward, right? Okay, now let's see E here, right? E here is we want to find the acceleration. And we know that A of t is dv over dt, right? We know the velocity is given by this function here. If you differentiate that function, you get 6t minus 12, which is 6t minus 2, right? Okay, you can calculate the acceleration at any time, right? Okay, now let's try to answer the last question, right? Now we want to, when we try to analyze the motion of the particle, the last one, have here, is we want to know when the particle is speeding up. When the particle is slowing down. We need to make a connection between the formula of velocity, acceleration, and speeding up and slowing down, right? Speeding up means v and velocity and acceleration share same direction, right? Both go to the positive direction, or both share the same direction. And slowing down means they have the same different direction, right? One go positive, the other one try to pull this, try to slow down the particle, right? Have a different direction. Okay, right. We know that v of t is given by what? Given by what's that? 3 times t minus 1 and t minus 3. Acceleration a of t is 6 times t minus 2, right? So we know that if you draw a timeline here, this is 0, right? Between 0, 1, this v here is positive. This is 1 and 3. And between 1 and 3 is negative. Between 3 and to infinity, it is positive, right? Acceleration is easy. Then less than 2, on the left side of 2, negative. On the right side of 2 is positive, right? This is velocity. This is acceleration, right? Acceleration. So from 0 to 1, positive v. From 1 to 3, negative v. From 3 to infinity, positive v. And from 1 to 2, negative acceleration. From 2 to infinity, positive acceleration, right? Now you can see that we have 2 intervals. They share the same direction, right? So speeding up intervals, which including 1 to 2 and from 3 to infinity, right? Because look at the division here, from 1 to 2, both negative. From 3 to infinity, both positive. Then slowing down interval, and from 0 to 1 share same different direction, and from 2 to 3, one positive, one negative, they are slowing, the particle is slowing down, right? So that's how do we analyze this movement of the particle using these dual tubes.